one side infinite limits and vertical asymptotes. So let us discuss about few functions which have vertical asymptotes, and then we'll try to find the limits from left side and from the right side for these functions, and then we'll try to conclude something in common between them, right? So could you tell me some functions which have vertical asymptote? I hope you understand what I'm trying to say with vertical asymptote. For example, the reciprocal function, right? 1 over x. 1 over x, if x is equal to 0, then what happens? Well, it is 1 over x, right? So in the denominator, we cannot have 0. So let me write it down so that it becomes absolutely clear what we're talking about. We're talking about a function 1 over x. Now in this kind of a function, x cannot be 0. So we have a restriction here that x is not equal to 0. Now if we try to sketch this function, what do we get? If x is positive, f of x is positive, right? It's a reciprocal function, and if you sketch it, so the graph of the function is kind of like this. Now here what you observe is that the y-axis is something which the function is approaching but never being there, right? So that y-axis is actually the vertical asymptote for the function. So this is the vertical asymptote. As we approach x equals to 0 from left side, the function approaches minus infinity. As we approach 0 from the right side, the function approaches positive infinity. So what I'm trying to say here is, what we observe here is that the limit of the function which is 1 over x, as x approaches 0 from left side, means 0 negative, is equal to minus infinity, and limit of the function as x approaches 0 from the right side, that means 0 plus, and the function is 1 over x, is positive infinity, right? Do you see that? And what do we get here is that x equals to 0 is a vertical asymptote. Correct? So that is what we see in 1 over x. Now let's take one more example. And this time we'll take example of 1 over x squared. So let's square this function. So if I take example of 1 over x squared, so my function now is f of x equals to 1 over x squared. So if I try to sketch it, how will it look like? So right hand side will be in quadrant 1, so kind of similar to 1 over x, but x squared, so the negative part will get flipped on the positive, so it becomes something like this, right? Now in this case, what do we observe? Can you tell me? So what has happened to the function? And does it have a vertical asymptote? It does. What we observe here is that the limit of the function so we can write limit of this function, which is 1 over x squared, as x approaches 0 from negative side, is equal to plus infinity. And limit of this function, 1 over x squared, as x approaches 0 from the plus side, is also equals to plus infinity. Well, in both the cases, limit does not exist. When we say approaching infinity, infinity is not a number, right? So it does not really exist. So in all these cases, limit does not exist. But again, what do we have here? We have a vertical asymptote, and the equation of vertical asymptote is x equals to 0, right? So we have a vertical asymptote, let me write VA, which is x equals to 0, correct? So here what we see is, as we approach a point value x equals to 0 from left side or from the right side, the function approaches infinity. In this case, it approaches positive infinity, and in 1 over x case, it approached negative infinity while we were approaching from the left side, and positive infinity from the right side. Got it? Now, if on approaching a point, the function approaches infinity, we say that a line x equals to that point, x value, forms a vertical asymptote. So in these two cases, x equals to 0 is a line which is a vertical asymptote to our function. Since as we approach x, as x approaches 0 from left side or right side, the function approaches infinity. Well, there are other examples where it is not necessary that we have the limit from both the sides. Now, for example, log x. So log x is kind of a function like this, right? It is reciprocal of, or rather inverse of, I should say, exponential function. So if I have a function which is f of x equals to log x, right? Let it be to the base 10. In that case, what is the limit of this function? Log x as x approaches 0 from negative side. That means from the left side. Well, from the left side, you cannot approach, right? Because that is not in the domain. Do you understand? That's not in the domain. So from the left side, we cannot approach. It does not exist. How about limit of this function, log x, when x is approaching 0 from the positive side? If you are approaching from the positive side, then the function approaches minus infinity, right? Here. So that is minus infinity. It is approaching minus infinity. Now, since the function is approaching minus infinity, as x value approaches 0 from the right side, we say that there is a vertical asymptote. An equation of this vertical asymptote is x equals to 0. So what we conclude from here is that if x is approaching a value a, in this case it was 0, and if function approaches undefined, unbound value of infinity, maybe positive or negative, then x equals to a, in this case x equals to 0, forms a vertical asymptote, right? So that is how one side limits and vertical asymptotes are related, right? So if one side limit is infinity, maybe plus or minus, then the line x equals to a, in all these cases it was 0, represents a vertical asymptote. So that is the relation between one side limits and vertical asymptotes, right? I hope with these examples the point is quite clear, right? We can give many more examples. Well, one of them, let me take a trigonometric function, tan x, right? So tan x, for example, has vertical asymptotes, right? Now it is kind of like this, where the vertical asymptotes are at 90 degrees, right? Or minus 90 degrees. Normally, a vertical asymptote is always drawn with a dotted line, right? So here, this dotted line represents the vertical asymptote for the function tan x. Now this point is 90 degrees, right? Or this is minus 90 degrees. So why it is a vertical asymptote? Since if x approaches 90 degrees from left side, let us say, so I will write minus here, the function tan x approaches positive infinity. Do you see that? So if the function approaches infinity, as you come closer and closer to that point, then the line representing, that means in this case x equals to 90 degrees, forms a vertical asymptote, right? So that is how we relate vertical asymptote with one side limits. So one side limit for a vertical asymptote is always undefined. It could be positive infinity or negative infinity. So that is the gist of the whole thing, right? So if one side limit is positive infinity or negative infinity, that means a vertical asymptote exists. So that's the takeaway from this video. I hope now you understand how closely one-side limits and vertical asymptotes are related. Thank you.